All right, good morning, everybody. Let's go ahead and begin. A couple of announcements. Remember that homework 11, that one problem related to budget limits, where you're considering different bundles of possibilities. That assignment is due tomorrow, and you need to upload it to Blackboard before noon. And then the other major thing that should be on your radar right now is the project. And yesterday I sent out an email with the assignment description, in case you've lost track of that, and also a link to a video. It was the lecture video where I first introduced the project, and I provided that link because I went into a pretty lengthy description of the overview and what I hope to see in the spreadsheet file. Now, when you're preparing the spreadsheet file, you're free to use whatever method makes sense to you, because everyone's circumstances are going to be unique in terms of your assumed expenses, maybe the way that you want to calculate what your investments are going to be. But then once you've done all of that preliminary calculations, it needs to be presented in a table that follows the format that I provided in the handout and demonstrated on the video. So if what you give me isn't in that format, then it immediately becomes a lot more difficult for me to understand what you did and whether it's right. And so the people who follow the formatting guidelines that I provided generally get better scores than people who try and reinvent the wheel on their own and then forget something along the way. So just my suggestion is review that video link. The entire description I think is about 25 minutes, but if you were going to just jump to one part of the video, I'd suggest focusing in on the overview of the spreadsheet, because I think that's really important. I got a question about the homework assignment, and I wanted to pass along the information I shared for that. So someone was identifying that, in each of the different things, your cousin's going to be a DJ and wants to buy some equipment. It all has different useful lives. You don't have to do repeatability. You just find the present worth of each item, and they don't have to be made to have the same duration. And the reason for that is that we're not comparing the items to each other. When we use the least common multiple approach or contract services or early termination, like when we were doing those sorts of operations, it was because we were trying to choose, should we do option A or option B, and those two things are competitors to serve the same task. But in the homework problem, that's not what you're facing. You're facing kind of independent projects that aren't competing for doing the same task, and so you don't have to make them all the same duration. Just find the present worth of each, and it's that individual present worth that should be included when you start to come up with the bundle values. So hopefully that's useful information. If you have specific questions on the homework assignment or the project, I'd be glad to talk to you after class. I have office hours after this and throughout the day, and I'll do my best to be responsive over the weekend if you have questions, but it's easiest for me to respond if your questions are specific. A question like, I don't understand the homework, I can't give you a specific answer when you give me a vague question. So try and be really focused on what you've tried already, what you understand, what you don't understand, and then I'll get back to you the best way that I can. All right, yesterday we kind of had to rush through part 3 on the in-class exercise. Remember that last time we did the capital rationing, budget limits, and then we changed gears a little bit and talked about the relationship between price and demand. And so we're going to spend a little bit more time going over that before we get into a different type of break-even analysis. I showed you this image in class yesterday and warned you that on the exam, what you'll have on some of the concept questions is a picture that you have to describe. And so maybe I'd provide this picture, but I'd take out some of the labels. And then I'd ask you, describe one of these curves. Not only don't just tell me what the name of the curve is, but describe what it means and what's happening. Basically, tell the story that is this picture. And so just to review some of the things that we discussed, remember that a company can have lots of demand by having low price, and if you have high prices, then the demand is lower. And so that's the relationship: high price, low demand; low price, high demand. That's the relationship between the independent and the dependent variable. So on this vertical axis we have amount of money. And what this shows is the revenue curve comes to a peak. There's some point of maximum revenue, D hat. And maximum revenue isn't the same thing as maximum profit, which is what we're trying to achieve, maximum profit. And so maximum profit is D star. And why is it that we have this range of profitable demand from D prime 1 to D prime 2? Who can explain why if we sell fewer items we're not profitable, and why if we sell more items than D prime 2 we're not profitable? So let's start with, if you sell less than D prime 1, what's the explanation for why you don't have a profit? Okay, you're not getting that much money. So why does that mean you're not profitable? So like if I was going to be argumentative and play the role of the devil's advocate, I'd say, well, yeah, you're not selling that much, but also your costs, your costs are lower too. So why aren't you profitable?
There's still a fixed cost.
Okay, fixed cost. So what does that mean? What's the significance of the fixed cost?
If you pay it no matter how many you make.
Okay. And so what does that say about my demand? You're right, by the way, but what does that say about my demand? Like the number of units that I need to be selling. Like if you were going to say, you have to at least sell enough units to blank, fill in the blank, yeah? Pardon me?
Break even.
To break even. So specifically, what does that mean? Like what is break even?
That revenue and the initial cost are the same.
Okay, that your revenue and initial cost. Initial cost isn't a phrase, we do use that phrase a lot, but not when we're talking about this figure.
You don't have to beat the initial cost, you also have to beat the variable cost for whatever.
Instead of saying initial cost, let's call it fixed cost here. Okay, so the fixed cost, you have to cover your fixed cost, so you got to sell enough to cover your fixed cost, which is the rent, the cost of having the equipment there, insurance, those things that whether you're productive or whether you're lazy, you always have to cover your fixed costs. So you need to sell at least enough to cover your fixed cost and whatever variable costs are associated with that level of production. So always look at how far apart is the revenue curve and the cost curve, because profit, remember the formula last time, profit is revenue minus cost. So graphically, look at when is revenue above cost. So when we're to the left of D prime 1, the reason why we don't have a profit is that the costs exceed the revenue. So you're not selling enough items, even though you have a good price. Remember, when we're down here in the lower end of demand, the few items we're selling, we're getting a good price for those items, but we're selling so few that it's not enough to cover the fixed costs and the variable costs for those items. All right, so that's explaining to the left of D prime 1. Who can explain what's the problem with being to the right of D prime 2? Terry? Shoulder shrug from Terry.
You're selling a lot of them, but it's costing more to make the product than you're selling them for.
Okay, you're selling a lot of them, and it's costing more to make than you're selling them for. So your costs exceed your revenues, and the reason why, you notice that the revenues are starting to go down. The revenues are going down even though we're selling more, because we're decreasing the price in order to get that additional sales numbers. So we're not charging enough. All right, so when we were working on the in-class exercise, let me bring the solution up again, because I just want to make sure that everyone got a good look at that solution and didn't have any questions on what we were doing. All right, so it was this one, and optimal demand, we have a formula having to do with the variable cost per unit, the price at which there's no demand, and the unit decrease in price that is associated with an increase in demand. So, those variables that we can get off of the problem statement. So we calculated how much revenue do we have at a certain amount of units. And so if this is the ideal number of units, then we find out what price do you have to charge to sell that much. So you put that demand into the price equation. The revenue would be the price you're charging and the number of units sold. The costs would be the fixed cost, and then the variable costs if you're selling 25 units and each one of them has $83 of cost associated with it. Then you find your total cost, and then the profit is the difference between the revenue and the costs. And then the range of profitable demand was just a matter of putting those numbers into the equation and not making mistakes. Now let me show you how we can graph this. I prepared an Excel spreadsheet that illustrates graphically what we've got. So if you put in just like a bunch of different demands, you can put in a column that has the price equation. So in our example, the price was 180 minus 0.02 times the demand amount. And so if we want to sell 300 units, we should set the price at 174. If we set the price at 160, we'll sell 1,000 units, and so on. So we can just go through a bunch of numbers and find out what's the price associated with that. The revenue would be the number of units sold times the price. And so this is how much money is coming in. Create a column for revenue, create a column for cost. So the cost is the fixed plus the variable. So we have a cost column, and then profit is just revenue minus cost. And that hand sketch that I prepared here at the bottom, where I was just kind of winging it to show a few things, the lower break-even point, the upper break-even point. We can be more precise by then graphing the cost line, the revenue line, here's the profit curve, and so on. So I just wanted to illustrate how you can create a spreadsheet to do these same sorts of calculations. You're graphing and you don't know at the beginning how much demand you should do. Like here it's showing from 0 to 5,000. Well, you'll notice I went all the way to 9,000 because I didn't know where these crossover points would be. I didn't know at the beginning where do you start to be profitable. And so the first break-even point you can get to just by looking at where does the profit go from a negative to a positive value.
How do you measure demand?
Well, for a company it would be the number of units that they're selling. But are you asking how would someone in the real world come up with an equation like this?
Right.
Yeah. Well, I think probably a marketing economist would look at competitors probably. Like if you have an idea of you're going to be entering a market where you're selling like these timing switches. So you'd look at who else is already making timing switches, what's the price that they have set, and not every shop sells the thing at the same price. Maybe Amazon selling at one price, Walmart at another. You maybe could find some specialty electric store. So it's mostly market research based. All right, so that's just a review of what we did last time. Any questions before we move on about this relationship between price, demand, and when we were talking about break-even here, break-even has two meanings. Break-even last time, what we were talking about is when you start to be profitable, when your revenue is greater than your cost. Today's use of the word break-even is going to be a little bit different. So just be aware that the context that you use the word can make it so that it has a different meaning. Here, break-even just means whether you're profitable. Some additional terminology. The book discusses when there's perfect competition, meaning that an item is sold by lots of different suppliers and there's efficiency in the market, and lots of people can sell the items, that there isn't so much capital requirements to begin producing something. You know, there are some things that it's hard to enter the market, you know, like launching satellites. There's not a lot of companies that launch satellites. There's more now than there used to be. You know, 10 years ago there was just NASA. Now there's NASA, Blue Origin, SpaceX, and many others as well. So you can think of perfect competition would be something that's made by lots of people. So let's see, I guess probably what I'd think of as something for which there's perfect competition is batteries. Like, there's so many different battery suppliers out there. Beyond just Energizer and Duracell, there's just tons of Japanese and Korean and Chinese manufacturers that sell batteries on eBay for next to nothing. It's like if you need a watch battery, you can have 10 of them sent to your house from China for $1. And it just doesn't make any sense to me, but there's just a really competitive market for some things. On the other hand, there are some products or services that are being provided by organizations that have a monopoly on the market, meaning that they're the only people that can supply it. So an example of that would be electrical or water. In historical terms, it used to be that governments would give monopolies for things like selling tea. Like there was only a single company that could sell tea in England for a while. You know, they had the monopoly on importing tea to England. I think it was the British East India Company. You know, so nowadays, usually the monopolies that we have to deal with would be utilities. Somewhere between monopoly and perfect competition, sometimes you hear about duopolies. And a duopoly is when there's really only two people or two organizations in a market. So people have described the American political system as a duopoly because there's only two political parties, whereas in a lot of other countries there are many political parties that are all kind of competing for voters' attention and loyalty. Regulations usually are in place that control monopolies so that they don't overprice their products. So the electric company has to get permission from the Public Service Commission here in West Virginia before they raise their rates. Otherwise, they could just really bleed you dry because you didn't have anyone that you could buy electricity from except for them. And they know that it's going to be very expensive and prohibitive for most people to start generating their own electricity. All right, so let's take the case of a company that's manufacturing Twinkies as an illustration of some additional terminology. So you can see it's coming off of an assembly line. There's all these machines that are generating Twinkies. Fixed costs, which we've talked about a little bit so far, are those things that don't change depending on how busy you are. So owning this equipment, you have to have a certain payment to whoever financed that equipment, regardless of whether you're using it or not. The rent for the building, salary for the managers doesn't change based on productivity or the level of effort. Here are some of the fixed cost items. They're usually included in an assessment of your fixed costs. And then the variable, which we've also started to talk about, in the case of this Twinkie production, would be the plastic that the Twinkies are in, the boxes, the sugar and diglycerides and vegetable oils and shortenings that go into Twinkies, the hourly labor, in contrast to the salaried employees, you know, like the managers, who they don't get paid based on the number of shifts they're working. Oftentimes the workers in the plant are getting paid on an hourly rate, and so that if the factory is running 3 simultaneous shifts through the course of the day, then they're going to have higher labor costs than they would if they only had a single shift running per day. So it's important for us to know the difference between fixed and variable costs. Here is a illustration of if we have variable costs and fixed costs, and then the blue line is when we stack them, when we're accumulating them together, where we have the variable and the fixed cost. And so the intercept of this blue line with the vertical axis represents the fixed cost. So total is fixed plus variable. This is if it's a linear relationship. Quite often, though, we have a nonlinear relationship. And think about why it would be that this curve would start to taper out. Like, what are the conditions that would make it so that your variable costs aren't going up as much as you make more and more? And this is the typical shape of a nonlinear cost relationship. Can you think of a case where, like a company that's making something, it's not as expensive for them to make a lot than if they just make a little bit? Why would that be? If you're making Twinkies, why would your cost, your unit cost, be going down to make 10,000 Twinkies a month compared to 5,000 Twinkies per month? Jeffrey?
Well, there could be the factor that competition has more or less disappeared, so you don't have to go at it so greatly.
Well, that may be true indirectly, but if the competition disappeared, then I think what that would affect would be the price that you're able to charge rather than your underlying costs. You know, like maybe if your competition went away, then the materials you're trying to buy would become cheaper, so that could affect your costs. But really what's it about is like a bulk discount. You know, like if you buy a lot of something, often a supplier is willing to give you a special deal. And so if you go to Kroger and buy a pound of sugar, you're going to pay a lot more than a Twinkies factory that's buying sugar by the truckload. You know, crate after crate, they're probably paying 50 cents a pound, whereas at Kroger you may pay $1.20 per pound for sugar.
If you go on a website where they sell a lot of like hardware and industrial materials,
Yeah.
they have different prices based on how many you buy.
That's right. And you can even see it when you go someplace like Lowe's. If you look on the shelf, sometimes they'll have a special tag that says contractor price, like if you buy 10 of them. So if you want to buy, 10 bathroom fans, you can get $1 off on each of those bathroom fans. Well, I don't need to buy 10 bathroom fans at a time, but someone who's putting in a subdivision maybe could. So this nonlinear relationship, what it's saying is that, see how it's flattening out? The reason it's flattening out is because the variable cost per unit is decreasing the more they sell. This is zooming in on the curve that you've seen before, the first break-even point. So what it's showing in this illustration is that so you have your cost line. And once we get past some break-even point, then this line below is the revenue line. So here's our revenue curve, here's the cost curve, and the break-even point where we start to see profit is where now our revenue is above the cost curve. So we've seen this before. This is nothing new. It's just maybe colored differently and zoomed in. QBE means the break-even point. And the first break-even point is what in the previous figure we called the D'1. All right, so keeping that in mind, what if your variable costs go down? So remember, here's our cost curve, the slope of the cost curve. What if it isn't as steep? Think about how that would shift where the break-even curve is. If this curve goes down, if I could drag it down, the crossover point shifts to the left. And that's what this is illustrating. It's showing that here is your original break-even point, but suddenly if flour or sugar, all of the things that you need to buy, if they become cheaper, now your cost curve isn't as steep, so that means you don't have to sell as many items to break even. So it shifted it to the left. Okay, so here's this same formula you've seen before for finding the break-even quantity, and this is if you know the fixed cost, the sales price per unit, so the revenue per unit, and then the variable cost per unit. So if you lower the cost curve, then the break-even point moves to the left. And this is a trend that you're going to have to remember and commit to memory. It could show up as a question on the exam, you know, a concept question. And the concept question would be, if your variable costs decrease, then what happens to the break-even point? And you'd say the break-even point shifts to the left, meaning fewer units need to be sold before you become profitable. Any questions about that relationship? What if your variable costs go up? What would that do to your break-even point? Exactly. So it would be the opposite effect. So if the total cost curve gets steeper, then the point at which those two curves intersect would be further to the right. Like if I could grab onto this line and lift it up, and the revenue curve stays the same. So if I'm just lifting the cost curve higher, then this point of intersection would shift further to the right. Okay. Break even here, what we've been talking about so far is the difference between profitable and not profitable. Now I'm going to start using that word break even in a different way. So now the way that I'm using break even means, how do you know whether to use one option or another option? So we have two alternatives of options, and I guess what we can think of them is two different ways to produce something you're going to sell. You know, do you want to assemble it by hand, or do you want to have robots assemble it? Okay, so think about these two curves. If you're just going to hire people to assemble it, probably your fixed costs are lower than if you have a robot. You know, the fixed cost, you got to buy the robot, and your capital recovery on the robot's going to be really high. But then what this is showing is that once you own the robot, your variable costs are low because you don't have to pay labor costs for the robot. You've got to give it a little electricity, maybe motor oil for the hinges. But unlike a person where you don't have to pay as much to get the person in the door and working, but the variable costs are higher. Okay, so that's why we've got two different curves. Just think as a, for instance, robot versus person. What this break even means is the point at which you should use one option versus the other. If I'm going to make relatively few items, should I choose the robot or the human worker? If I'm just going to make a few. Human. Why? You're right. Why? Why should I have the human?
Because it's cheaper before the break point.
Because it's cheaper. Like, this one was human, this was the robot. So the human is less expensive if you're just going to make a few, if you're not going to make a lot. Why is the human less expensive? You know, like if I was being argumentative and not looking at the data, I'd say, how can a human be more expensive than a robot? A robot works for free.
Robot costs a lot more to start with.
Okay. The fixed costs are higher for the robot because you've got to pay, you know, $200,000 just to get the robot in the door. Okay. So if we're using the language of fixed and variable costs, the person who's being argumentative, all they're talking about is the variable cost. They're saying, you know, how could the robot be more expensive? You don't have to pay the robot. So they're saying, but really the translation of their argument is, but the variable costs are lower for a robot than they are for a human. And then your reply is, yeah, that's true, the variable costs are lower, but the fixed cost for the human is way, way, way lower than the fixed cost for a robot. And so what's more important on the left side of this break-even point is that the fixed costs are so much lower that the additional variable costs don't really matter that much until you get to the break-even point. Now, so here, the break-even point is the point at which you change from wanting to have the human do the job to wanting to have the robot do the job. So think about what this break-even point means. It means Suddenly now you're making so many of the thing that even though the human was cheaper to get in the door, you're paying so much for labor that it would be better to have the robot, because you don't have to pay for the robot's labor, and you're making enough of the thing to justify that fixed cost of the robot. Okay, so does everyone understand what this break-even point means? It means to the left of the break-even point, use the item that has a lower fixed cost but a higher variable cost, because you're not making that many. So the variable cost doesn't have that much of an effect. But then to the right of the break-even point, no longer should you choose option 1. Now you should choose option 2, because to the right of that break-even point, option 2 is the lower cost. And our objective here, the criteria that we're aiming for, is minimize costs. I mean, that's the way to maximize your profits, is try to get high revenue and low costs. What's the best combination of high revenue and low costs? That's what a company is going to be aiming for. So what we're trying to determine is which alternative to select, and the answer is dependent on how many items you're producing.
Will we ever have a question that combines like what we went over previously? Like we gotta find the break-even points and then choose between the two options? Or will it be?
So you mean like a question where you're doing like this kind of an analysis and you've got two alternatives?
Yeah. And then we have to choose between the two alternatives.
I've never asked a question like that, but that's a great idea. Maybe I will. Maybe what I could do is I could say, create, you know, like how I did on the spreadsheet. Here's the situation for option A. You make this curve, and I'd say, here's the cost set up for option B. So you'd make a similar curve, and then I'd say, and we know we need to make X items. So which alternative should you select? That would be a good question. Maybe I'll try and cook something like that up. Thanks for the brainstorming.
You're welcome.
Yeah, all right, good. I'm just fooling around. All right. Usually, I mean, they'll be separate. Like today's in-class exercise, we're only doing the one. We're just doing the decision between two alternatives. Like if you're going to do a certain amount of volume, should you choose option A or option B? Now I've got an Excel template on the back side of the page where I suggest how to set things up in order to answer these questions. So a company has equipment to produce something. Option 1 is the expensive first cost, computer controlled. It costs more to buy, but it lasts longer. It's got some salvage value. It has lower labor costs and is more productive, meaning it can generate more items every hour. It's faster than the humans are. So in questions A through E, I'm asking you to consider, you know, should you go with option 1 versus option 2, and setting it up according to the template that's on the back side of the paper there, which I'll bring up on the screen here in just a second, will give you an idea of how to start with the calculations. My suggestion when you start setting this up is actually put in the values that you know. So it says that the interest rate is going to be 9%, and the first part, like in part B, is the first time we hear about any sort of volume. and it says 1,000 units per year. So put in 1,000. Oops, I put it in the wrong cell. 1,000 units per year is the first time it's talking about quantities. And where you have this 1,000 units per year, notice what this is saying. How many hours are needed to make 1,000 units if what we know is that option 1, the output is 3 units per hour, and then the other one is 2.4 units per hour. So this is how many hours do you need to operate in order to make 1,000 units. So you're going to need fewer hours with the computer-controlled equipment. You're not going to need as much time to make that same 1,000 units if you have the computer-controlled equipment. Okay, so if we're making 1,000 units per year, the assignment says the first cost for the option 1 is 2 million, so we have to put in negative 2 million because it's an outflow, whereas manual control is 1.3 million. Okay, the predicted life 10 years versus 7 years. Salvage. So I'm going to have the salvage be positive, whereas the cost was negative, because they're in opposite directions. The labor costs are 180 an hour versus 195 an hour. Okay, we've already talked about productivity. The computer control allows me to produce more units per hour, so the number of hours I need is how much is being made divided by the productivity. So you don't need as many hours if you have the computer equipment than if you have manual control. You need more time to make the same 1,000 units. Capital recovery is we're finding an annual series. So we're turning a first cost and a salvage value into an equivalent annual amount using the payment function. Put the purchase price in the present value, the salvage in the future value. Alright, so of the two, if you're only making 1,000 units per year, it's, hold on a minute. Yeah, that's right. It's cheaper to go with option 2. I did something called conditional formatting where it bolds the lower of the two. Let me show you how that works. If you highlight 2 cells and you go into the conditional formatting, then what I'm going to do is, let me clear the existing rules. Let me do a new one. So I do conditional formatting. I'm highlighting 2 cells right now, and I want it to be a new rule where it's going to take the highest value, no, let's see, yeah, the highest value of the 2 would be least negative. And the, I don't want it to be colored. Yeah, I'll do a, yeah, the top one will be bolded. Okay. So what it's going to do is, of the 2 that I have highlighted, it'll take the top one and bold it. I went into the formatting there, and so you can see The cheaper alternative is bold just to make it more obvious. And so once we have it set up, we can change the productivity from 1,000 units per year to 3,000 units per year. And it's automatically going to change which one is bolder. And we can find out that option 1 is now the cheaper way to go. If you're making a lot of the items, then paying extra for it is worthwhile because of this improvement in productivity. So your costs per year are less when you're going to be making a high volume. For the last part, for the goal seek, my suggestion is that over here off to the side, you should have an area where you're calculating the difference between option A and option B. And that way your goal can be to make the difference equal to 0. So you'll set up your goal seek, and the what if analysis is going to be, the goal seek will be change this so that the difference is equal to 0, the difference in cost between the two.